With the launch of the James Webb Space Telescope in 2021, it seemed fitting that one of the first images this telescope should take was of the Pillars of Creation. Fitting because in 1995, the Hubble Space Telescope captured an image of the Pillars of Creation that became one of the most iconic pictures ever taken of an object within the universe. So let's take a look at some of the images the James Webb Space Telescope, or JWST, has given us, and see how some of them compare to the original images of the Hubble Space Telescope. Operating in the infrared portion of the electromagnetic spectrum means that the James Webb Space Telescope is better able to peer through the dust cloud and give us details not seen before. This is why in its Pillar of Creation image more stars are showing when comparing it to Hubble's image. The James Webb Space Telescope image of the Southern Ring Nebula shows a better resolution of detail than Hubble's. We can now see a central star which is merely acting as a supporting role in the nebula's creation, caused by the remnants of a dying star which is barely visible and down to the left of the central star. Across millennia, this star has expelled 8 tiers of particles, and with the turbulence caused by the interplay between these two stars, the nebula has formed this shape. The Carina Nebula, or cosmic cliffs as they are commonly called, are on the edge of a giant gaseous cavity which can be 7 light-years in height at their tallest point. The JWST image is better able to penetrate the dust and so therefore picks out more stars than can be seen in the Hubble image. Ever wondered what it must have looked like when the Sun and planets were formed? This image of L1527 should give you an idea, as concealed within the slender neck of this hourglass configuration rests a protostar which is shrouded from direct observation. Positioned edge-on, manifesting as a dusky streak cutting across the central expanse of the neck, is a protoplanetary disk, about the size of the solar system. Radiance emitted by the protostar spills both upwards and downwards past this disk, casting its glow within the encircling shroud of gas and dust. The Rho-Ophiuchi cloud complex is the closest star-forming region to Earth, where there are signs of planetary systems in the early stages of formation, as evident in these hourglass shapes which are similar to those just shown for L1527. Stellar winds from this star are also thought to be moving the dust and gas in this region of space, forming a cave that the star now sits in. At 340 light-years across, Webb's infrared camera shows a star-forming region of the Tarantula Nebula, where tens of thousands of stars can be seen. The middle of this image shows a tightly grouped cluster of stars as small pale blue objects. Under the gaze of the JWST, Saturn appears extremely dark in this infrared image. This is because the methane gas present within the planet's atmosphere has effectively captured nearly all the sunlight, and so casting an absorbing veil over Saturn. In stark contrast, the icy rings maintain their luminosity, resulting in the distinctive and unconventional image of this planet. Neptune, captured here in the infrared, shows off bright spots and streaks which are caused by methane ice clouds against the backdrop of the darker methane, which itself has absorbed any red and infrared light. Some of Neptune's 14 moons can also be seen, with some appearing as bright spots within its ring structure. Jupiter looks different in this infrared image, where auroras are visible at high altitudes at both the north and south poles. The Great Red Spot is now white as it reflects a lot of sunlight back, with numerous bright spots and streaks being high-altitude cloud tops of condensed convection storms. Stephan's quintet represents the largest image to date from the James Webb Space Telescope, where the coverage is about 1/5 of the Moon's diameter. 4 of the galaxies are truly close together, with the 5th leftmost galaxy well in the foreground at 40 million light-years from Earth, compared with the others at 290 million light-years away. Formed 400 million years ago from high-speed collision of 2 galaxies is the Cartwheel Galaxy. It is composed of 2 rings, a bright inner ring and a colourful outer ring, with both rings expanding out from the centre of the collision like shockwaves. I shall leave with a deep-field image of the James Webb Space Telescope peering back in time. Covering a patch of sky about the size of a grain of sand and held at arm's length from Earth are thousands of galaxies, including some of the oldest objects ever observed. This includes Glass Z13, a galaxy that formed only 300 million years after the Big Bang. Thank you for watching this far, and if you enjoyed the video then please consider liking and subscribing, and don't forget to hit the notification bell to get more content from me, the Cosmic Skipper.